All right, so greatest common factor of 24 and 35, that would be the biggest number that divides into them. So one way to figure that out is to make a factor tree and say, all right, 4 times 6 is 24. I can break 4 down as 2 times 2. I can break 6 down as 2 times 3. So 24 is 2 to the third power times 3. Okay. What about the 35? 35 is 5 times 7, both of which are prime. So those are my guys. So it's just 5 times 7. Okay. So now we want to figure out, all right, what is the greatest common factor? The biggest thing that is going to divide into both of them. Okay. Well, it's got to be common. It's got to work for both. Well, does 2 divide into both? Nope, there's no 2's over here. Does 3 divide into both? Nope, there's no 3's over here. How about 5? No 5's over here. How about 7? Nope, no 7's over here. So the greatest common factor, there is nothing, so it's just 1. 1 is the biggest number that divides into both of them. Okay, let's try this one. 16, whoops, I gotta draw the 16 first. 16 is 4 times 4, and each 4 is 2 times 2. So 16 is 2 to the 4th power. So there are 4 2's that constitute 16. Right, and 36 is 4 times 9, or 6 times 6, or 2 times 18. Then I get a 2, 2, and a 3, 3. So 36 is 2 squared times 3 squared. Right, so the GCF, okay, so we're looking for what's common, what's going to work for both of them. Okay, how many 2's do they both have? Well, this guy's got 4 of them, and this guy's got 2 of them, so they both have at least 2. So I'm going to go with the smaller amount. How many 3's does this guy have? None. This guy has 2 3's. The smaller amount would be no 3's. So that exhausts all of our factors, 2's and 3's. So 4 is going to be the greatest common factor, the biggest number that divides into both. All right, so now we're going to factor linear binomial. In other words, we're going to pull out the greatest common factor. Factor out the greatest common factor. Well, the biggest thing that divides into 12 and 15, their greatest common factor is 3. So I could rewrite this as 3 times 4u plus 3 times 5. And just rewrite the 12 and the 15 using that greatest common factor of 3. Now, I'll be honest, I'm not going to write it out this way usually, not for very long at all, in fact. So now we're going to do the opposite of the distributive property. For example, the distributive property says if I've got something like this, the 2 multiplies and I get 2x, and I get 2 times 5. Okay, but what if I wanted to go from here back, go the opposite direction? Well, I would take these 2's and pull them out. Okay, that's what I do. And so that's what I'm going to do over here. I'm going to take these 3's, the greatest common factor, and I'm going to pull them out. And what's left is 4u plus 5. And you're going to get real good at this if you aren't already good at it. And so that'll be very helpful. Okay, so now we're going to find the greatest common factor of 12m cubed and 16b. Well, this guy's got, well, we could write 12 as 2 squared times 3. And we could write 16 as 2 to the 4th times b. Okay, so this guy has a pair of 2's. This guy has 4 2's. We always go for the one that has fewer. Okay. This guy has 1 3, this guy has no 3s. So the one that has fewer is no 3s. 3 M's, no M's. 1B, no B's. So the only thing they have in common is 2's. Okay, they both have a couple of 2's in common, and the answer is 4. Now we do the same thing again, except there's one extra term, so who cares? 21 is 3 times 7. 14 is 2 times 7, and then you got those 3 U's. And then 3 doesn't factor, it's prime. So those are my 3 guys. All right, so I see 3's and 7's and U's and 2's. Okay, so the minimum number of 3's they have is no 3's. Okay, so no 3's go in the GCF. The minimum number of 2's is 0, because a couple of them don't have any 2's. Okay, so no 2's in the GCF. Minimum number of 7's is 0, because one of them doesn't have any 7's. And the minimum number of U's is 0. So there's nothing to pull out of this. So it's just 1. Very anticlimactic. And we'll do one more of those. So we've got 3 to the third is 27. 3 to the second is 9. And 2 times 3 squared is 18. Okay, so they all have at least 2 3's. Cool. All right, so wait a minute. Oh, write this. That would be cool. So they all have at least 2 3's. That's the minimum. And they all have at least 1 W. So 9W is it. That is the greatest common factor. Once again, the greatest common factor, well, 12 is still 2 squared times 3. And then 5 U's and 7 X's. And then 20 is 2 squared times 5, 4 times 5. And then 3 U's, 7 X's, and 4 Y's. Okay, so our greatest common factor. Okay, they all have, they both terms have at least 2 2's. So throw a couple of them in. They don't both have 3's, and they don't both have 5's. So no 3's or 5's. They both have at least 3 U's and 7 X's, but the first term doesn't have any Y's, so we're not going to include any Y's. So that would be 4 U cubed X to the 7th, and that's the GCF. All right, so now we're just about doing the same thing. Okay, so what divides into 4 and 6? 2. And they both have at least 1 M. So that is what I can factor out. That's the greatest common factor. And so, the 4M squared, that was 2 times 2 times M squared. So I'm pulling out a 2. I'm pulling out one of the M's. So I'm left with 2 M's right there. Okay. And then on that 6M, that's 2 times 3 times M. So I'm pulling out 2 M's, or 2 and M, and I'm just left with 3. So a 3. And because it was minus in the middle, it's still minus. And then that's it. Okay, and then I can, I could multiply back through and see if I got what I started with, and that would be cool. Or I could check it on the calculator. Let's do one of those right now. So once again, when I check this on the calculator, I want to verify that what I started with and what I ended up with are equivalent, because they're supposed to be the same thing, just written in 2 different ways. All right, so I'm going to go to the table, second graph, and look at that. The original problem and the final, they match up. Doesn't matter what I plug in for X, they match. And therefore, I know I've made no mistakes. You should be checking everything. And now we factor again. What's the biggest thing that divides into 30 and 10? That's going to be 10. And then they both have at least two V's, and they both have at least 2 W's. and they don't both have x's. Okay, so there's our GCF. So when I pull a factor of 10 out of 30, 30 divided by 10 is 3. I pulled out 2 v's, that's both of them. I pulled out, oh, that was supposed to be sorry about that. Supposed to be 2 w's. I think I said 2 and I wrote 3. I'm going to pull out a pair of w's. Well, there were 3 there, so if I pull out 2, there's 1 left over. Okay, then on the second term, I pull out a 10, and well, that's the only coefficient there was, so that's gone. I pull out a couple of v's out of 9 of them, so that means there's still 7 left over. I pulled out a pair of w's, that's all there was, so they're both gone. And I didn't pull any x's out, so all 6 of them are still there. And then you can multiply back through if you want, and see if you end up with what you started with, just to check your answer. All right, now on this one, we're going to, we notice that we've got u minus 5 appearing twice. Okay, this problem is basically just like saying 3x plus 5ux. We say, hey, they both have an x. I can pull an x out of there, and I end up with that, similar to what we were just doing. Well, it's not an x. It's actually a u minus 5. So that's what we're going to pull out. So we pull out a u minus 5, and we're left with 3 plus 5u. That's how it's done. That's it. That's going to, so practicing that will help you get used to the idea of factoring by grouping. And now it's time to do factoring by grouping. And when you see 4 terms, then you know that if you have to factor it, probably factoring by grouping is the way to go. All right, so first thing you do, group them up. Group up the first 2 and the second 2. And then just do a regular GCF problem on both. So in that first binomial, I can factor out 3y's. And if I do, I'm left with 4y minus 3. Out of the second group, I can factor out a 7. And if I do, then I'm left with 4y minus 3. And you'll notice the stuff in the parentheses is the same. That has to be the case. If not, then I can't finish the problem. So now, just like that last problem I did, I can pull a 4y minus 3 out of both. And I'm just left with y cubed plus 7. And yeah, that's how we do it. Let's do one more of those. All right, let's do another one. This one is significantly different, only in as much as the middle sign is a minus. Why is that significant? Well, let me show you real quick. It's not a real big deal, but I do need to give you an example. So I'm going to group them up again. Okay. And out of the first binomial, business as usual, I can pull out a couple of u's. So that leaves me with u minus 1. Don't forget the minus 1. And then on the second binomial, because this guy in the middle is negative, the way it turns out is whatever you factor out, in this case, a 7 for your greatest common factor, make sure it's a minus, and then things will work better. That's just the way these things tend to go. So if I factor out a negative 7, I'll be left with a positive u and a minus 1. Well, that makes sense, because if I multiply it back out, negative 7 times negative 1 gives me positive 7. When you factor out a negative, it always changes the sign. And then that way, by doing that, these end up being the same. So that's the tiny little extra thing you need to worry about when that middle sign is a minus. Okay. So now I can factor out a u minus 1, and I'm left with u squared minus 7. And that's all there is to it. Alrighty, on this one, same thing. Now there's an extra variable, who cares? So I'll group them up. There's that minus sign in the middle, so I gotta handle that. Okay, so in the first binomial, I can pull out an x, and I'm left with u minus 8. In the second one, I'm going to factor out something negative because of that middle sign. And the only thing I can pull out is a 2. And I'm left with 2u minus x squared. And uh-oh, these guys don't match. Which means I can't go any further. So what do? It just means that when I grouped them up, well, I didn't group them correctly. Okay, and what I mean by that is that, well, you could reorganize these things a little bit. For example, I might swap these two terms. Just move them around is all, not a big deal, so that it looks like this. And I haven't done this one already, so I don't really know what the right answer is. Okay, so I got that. Now I'll try it again. Let's group them up, and we'll see how it goes. So I'll pull a u out of the first binomial. That's a 4. I know it's hard to tell. And then I'll pull a -2 out of the second. Oh, a -2x. They both have x. And then I'm going to be 4 minus x. Okay. Hey, they almost match. Okay. One's x minus 4, one's 4 minus x. Okay, so this is one of those rare instances when that middle sign is negative, when you actually want to just pull out a positive. So if I pull out a positive, then the signs in here don't change. Okay. Then that's still minus from there. It's still that minus. And then this plus is still plus. And if you want, I can explicitly write this and say, all right, this guy right here, that's just x minus 4. Now they are the same, so now I can proceed and factor the x minus 4 out of both, and I'm left with u plus 2x. So sometimes you kind of just got to juggle the order of the terms, okay? But you have to have these guys be the same, otherwise the deal is off. You're not going to be able to proceed.